Welcome to part 2 of the PEI crop rotation instructional video. In this section, we'll explore the calculator's tabs and customization features through a hypothetical scenario, demonstrating how the calculator can be tailored to meet the unique needs of users and their specific farming conditions. We'll be delving into a scenario involving Pierre, a potato farmer, to showcase how these features can be applied to real-world farming situations. Some background information. Pierre is a potato farmer in Prince Edward Island who specializes in growing mini potatoes, which he sells at a premium price to a local company. This niche market results in lower yields but higher prices per kilogram compared to other farmers producing medium and large-sized potatoes. Pierre currently follows a 3-year crop rotation of mini potatoes, barley, and forage. He is now considering switching to a 4-year crop rotation that includes mini potatoes, winter wheat, barley, and forage. Pierre aims to use the PEI crop rotation calculator to help evaluate whether adopting the new 4-year rotation might be more profitable than his current 3-year rotation, while accounting for potential yield changes, costs, and benefits. Let's walk through how Pierre can use the customization features of the crop rotation calculator to evaluate this new 4-year rotation. Step 1 would be to explore the Crop Combinations tab. Pierre uses the Crop Combinations tab in the calculator to test different crop sequences and assess performance under both the current 3-year rotation and the proposed 4-year rotation. He enters the 4-year rotation into the Dashboard tab alongside the current 3-year rotation for comparison. However, since mini potatoes are not present in the calculator, are not preset in the calculator, Pierre must first input the relevant data for mini potatoes into the Crops tab before proceeding. Step 2 would be moving on to the Crops tab so that Pierre can review the net operating income and costs for each crop in his selected rotations. So you would check the preset values, essentially the revenue, the variable cost, the non-variable expenses, as well as the pesticide application for crops to ensure that the data matches his farm's specific conditions. As you can see here, you can scroll over and double check all of the preset values for his selected crops. However, for mini potatoes, Pierre will need to input values under the column Custom Crop 1, which he can relabel mini potatoes, which I have done here and filled out for the sake of time, but we'll go through each step. Now for on-farm revenues for mini potatoes are calculated based on marketable yield, target selling price, and additional premium earned from the niche market value. For marketable yield, this refers to the amount of mini potatoes Pierre can harvest per acre. Mini potatoes typically yield fewer kilograms of potatoes per planted acre than regular potatoes. Now, while this can vary based on growing conditions, management practices, and potato varieties, for this example, he will assume a marketable yield of 200 CWT per acre. Target price represents the expected earnings a farmer anticipates per unit of potatoes sold. He will assume a target price of $17.87 per CWT. Premium, this represents the additional value Pierre earns per kilogram from selling mini potatoes compared to regular potatoes. So Pierre, for this specific value, Pierre is going to assume $15 per CWT. Now for variable costs, the variable cost for mini potatoes might differ from regular potatoes due to variations in management practices, application rates of the following inputs, and potential different pest and disease pressures. For fertilizers, mini potatoes generally require slightly lower fertilizer costs compared to regular potatoes as they need less nitrogen and potassium per acre. So here, Pierre will adjust the cost to 900 per acre, reflecting these reduced nutrient requirements while maintaining sufficient application rates to support optimal yields. For pesticide or herbicides, mini potatoes may have slightly lower fungicide costs because they're typically top killed earlier than regular potatoes. This means that the above ground parts of the plant are treated with a desiccant earlier, which removes the need for fungicide at this stage. As a result, fungicide applications are reduced by about 20%. Therefore, Pierre will adjust the cost to $475 per acre to reflect this reduction in fungicide use while still maintaining effective pest management. For custom work and fuel application, they're non-applicable for this specific example. For labor, harvesting mini potatoes can be more labor intensive because of their smaller size and the extra need to avoid damage. So the labor costs are going to be assumed to be $600 per acre to reflect this. For non-variable costs, these costs are similar to those for regular potatoes. Those specific expenses might vary slightly based on factors such as equipment or storage needs. For seeds without treatment and cutting, since mini potatoes do not require seed cutting, this reduces the overall seed preparation cost. So Pierre will adjust the total seed cost to $485 per acre, accounting for these savings. For machinery, going to assume a cost of $499.59 per acre, although mini potatoes might require different or additional equipment. For machinery maintenance and repairs, it's going to be assumed that the cost will be around $709.23 per acre. For fuel used on field irrigation system, fuel used for irrigation system, these costs are not applicable for this specific example. For storage, mini potatoes are generally stored in 1-ton boxes instead of bulk, which increases storage costs. So Pierre will adjust the storage cost to $485.62 per acre, reflecting an estimated 20% higher cost compared to regular potatoes. For drying and trucking, Pierre's going to keep the drying and trucking costs for mini potatoes similar to those for regular potatoes. He'll set the drying cost to $50 per acre and the trucking cost to $75 per acre, reflecting local processing and short distance transport arrangements. For other costs, they're likely similar to regular potatoes, so Pierre's going to assume $110.56 per acre. Now, for pesticide application, mini potatoes are top killed 2 to 3 weeks earlier than regular potatoes, so Pierre can expect about 12 pesticide applications instead of the 15 typical for regular potatoes. And this is assuming similar pest and disease pressures. The next step would be to analyze the assumptions and scenarios in the comparison tab. Now, here, Pierre will compare the different rotation scenarios over a 12-year cash flow period and adjust the assumptions to reflect his specific conditions. It's important to note that these adjustments in fertilizers and pesticide and herbicide applications, as well as yield improvements, may vary based on several factors, including soil type, local pests and disease pressures, weather conditions, and the specific crop varieties used in the rotation. For the current 3-year rotation, it's assumed that there will be no specific changes in pesticide use, fertilizer application, or crop yields over time. However, after talking with neighboring farmers, Pierre learns that switching to a 4-year crop rotation can potentially help improve soil health and control pests. So he learns that by changing the forage from a more grass-based forage to a more legume-based forage, he can reduce his fertilizer use by 10% in the years that he grows mini potatoes. And the legume-based forage will actually help enrich the soil with nitrogen, benefiting mini potatoes in subsequent years. However, he learns that with winter wheat and barley grown before the forage, that they generally will remain unchanged, like the fertilizer requirements. So Pierre's going to adjust the fertilizer use for each crop in the rotation and input these changes for all the cycles over the 12-year period as follows. So for mini potatoes, which are grown in years 1, 5, and 9, there's going to be no fertilizer reductions assumed in year 1, as the legume-based forage has not yet enriched the soil. However, in years 5 and 9, a 10% reduction will be applied, taking advantage the nitrogen enrichment from the legume-based forage. So we can go ahead and enter in these changes. Now for winter wheat, which is grown in years 2, 6, and 10, no fertilizer reduction is going to be assumed because they remain unchanged due to their nutrient needs and they're unaffected by the forage change. And barley, which is grown in years 3, 7, and 11, we're also going to assume no fertilizer reduction. It remains unchanged due to its non nitrogen fixing nature. And for forage in years 4, 8, and 12, this forage is now legume-based, which enriches the soil with nitrogen and contributes to reducing fertilizer use in the potato years, but no direct fertilizer reduction is applied to the forage crop itself. However, Pierre also plans to reduce pesticide use by 8% during the years he grows mini potatoes by adopting more sustainable pest control methods. So, for barley and forage, pesticide use will remain unchanged since these crops typically require minimal pest control. Similarly, pesticide use for winter wheat will stay the same due to its low need for pesticides. However, extending the crop rotation in general reduces overall pesticide use as the pest management intensive potato years occur less frequently. So, Pierre will input the adjusted pesticide use for each crop across all the rotation cycles over the 12-year period as follows. So for mini potatoes in year 1, 5, and 9, an 8% pesticide reduction is applied through more sustainable pest control methods. So we can go ahead and input these changes to year 1, 5, and 8. Sorry, year 1, 5, and 9. Now for winter wheat, which are years 2, 6, and 10, no pesticide reduction is assumed and standard use continues. And for barley, which are years 3, 7, and 11, there's minimal pesticide use, so Pierre's going to assume no reductions. And for forage, which is grown in years 4, 8, and 12, it's a standard pesticide use, so we're going to assume no reductions. Now, while crop yields are expected to increase by 5 to 15% annually in this specific example, due to improving soil health in the longer rotation, Pierre has decided to not account for these improvements during the first rotation. Starting with the second rotation, he anticipates steady yield increases for mini potatoes, winter wheat, as well as barley. Now, forage crops may not experience direct yield gains, but will enhance the soil health, benefiting other crops in the rotation. So, Pierre will adjust the yield estimates for each crop across all rotation cycles over the 12-year period as follows. Again, as we mentioned for the first year rotation, so these are years 1 to 4. No yield increases are applied to any of the crops. However, in the second rotation, which are years 5 and 8, and subsequent rotations in years 9 to 12, for mini potatoes in years 5 and 9, we're going to assume a gradual increase of 10% in year 5, and then 15% in year 9. Now, for winter wheat in year 6 and 10, And barley in year 7 and 11, we're going to assume a moderate annual yield increase of 5% is applied. And as we mentioned for forage, there are no direct yield increases, but indirect benefits through soil health benefiting subsequent crops. So the next step would be to review the results. So Pierre will then review the results by checking how the net income changes in the new rotation. And he can also adjust the assumptions to calculate NPV. So to calculate NPV in this specific example, Pierre actually decides to maintain a discount rate of 7%, considering it a solid benchmark to account for the typical returns and risks in his operation. So the next step would be to review the results in the dashboard tab. So to evaluate whether Pierre's hypothetical new 4-year rotation may be more profitable than his current 3-year rotation, he's going to analyze both the cost efficiency and profitability over time. So for cost efficiency, by examining the average revenue cost ratios, Pierre can determine which crop rotation maximizes profit while minimizing input costs. The 4-year rotation demonstrates greater cost efficiency in the middle years as reduced pesticide and fertilizer use lead to lower overall cost. This efficiency makes the 4-year rotation more attractive in certain cycles as it allows Pierre to retain more profits compared to the 3-year rotation, especially in this especially in the middle cycles, although the 3-year rotation does experience significant reduction in costs in later cycles, providing a more even balance between revenue and expenses. So Pierre should also consider, though, the long-term profitability, which is more effectively understood by comparing NPVs of both rotations over an extended period of time. So when considering long-term profitability, the calculator projects that the 4-year rotation offers larger cumulative profits over a longer period based on the variables supplied by Pierre. Although the 3-year rotation might generate faster returns in the initial cycles, the 4-year rotation provides better long-term profitability by reducing the need for expensive fertilizers and pesticides in later cycles. While the 3-year rotation might appear more advantages in the short term, the 4-year rotation results in a higher overall NPV when assessed over a longer time frame. This suggests that switching to the 4-year rotation could help Pierre achieve a more stable and profitable financial trajectory over a longer term, with benefits that outweigh the short-term gains from the 3-year rotation. So the primary choice would be the 4-year rotation. In this hypothetical scenario, the 4-year rotation appears to be more profitable over the long term with a higher NPV over 12 years. It also provides better cost efficiency in the middle cycles due to its reduced input costs, although the 3-year rotation offers higher profitability in the earlier years, the 4-year rotation's slightly higher cumulative profits make it a stronger choice for long-term profitability and sustainability. Now, consideration, the 3-year rotation remains an option for Pierre, especially if he's looking for quicker returns in the first few years, while the NPV over the 12-year cycle is slightly lower. For the 3-year rotation, its cost efficiency in the third cycle and quicker financial returns from earlier cycles may make it appealing. Furthermore, the higher NPV of the 4-year rotation does depend on the discount rate. For instance, if Pierre's loans have an interest rate of 10%, the 3-year rotation could potentially have a higher NPV at that rate, enabling him to generate revenue sooner and pay down debt more quickly. If immediate financial stability and flexibility are priorities, the 3-year rotation may still be the preferred choice. And this is just a summary of the steps that we just outlined. So thank you for joining us in exploring the PEI crop rotation calculator developed under the Atlantic Living Labs project. We hope this instructional video has provided you with valuable insights and how this tool can help you to explore different crop combinations and rotations and their potential impacts on your farm. If you have any questions or need more clarification on using the calculator, please contact us via the following emails on the screen. Your feedback and inquiries are invaluable as we continue to support sustainable agricultural practices in Prince Edward Island and beyond.